Good morning students. Today we will do a new topic in chemical bonding chapter which is called hybridization. So this is totally new concept. Now what is hybridization? Already we have done valence bond theory VVT, and by applying valence bond theory you can explain how a covalent bond is formed between two atoms. And according to valence bond theory, the half-filled orbitals present in an atom, they undergo overlap with the another half-filled orbital of another atoms or similar atom to produce the covalent bond. I mean, when a covalent bond is formed, the orbitals undergo overlap and the orbital should be half-filled. And like that way, we have drawn number of molecules. We have drawn oxygen molecule, how O2 is produced, how the double bond is produced between two oxygen atom. Nitrogen molecule we have drawn, how the triple bond is produced between two nitrogen atom. Fluorine molecule we have done, how hydrogen molecule we have done, how the single bond is present between hydrogen, how it is formed. But it is found that there are some molecule, for example methane, you know, CH4. If you want to explain about the formation of methane CH4 by applying valence bond theory, you cannot explain. So valence bond theory fails to explain the formation of methane molecule by applying that concept. You know, methane formula is CH4, and you know atomic number of carbon is 6, and that's why its electronic configuration is 1s2, 2s2, 2p2, and that is why the 1s2 it is filled up, 2s2 it is filled up, 2p2, since there are 3 p orbitals, one is called 2px, one is called 2py, one is called 2pz. How many electron present? 2 electron present, and they should be present like this. So how many half-filled orbitals in carbon? In carbon there are 2 half-filled orbitals, and as you know, only half-filled orbital can undergo overlap. I mean, only these 2 orbitals can undergo overlap with other orbitals. Now suppose this is one hydrogen 1s, it contains 1 electron, and this is hydrogen 1s, it contains, this is one hydrogen, this is another hydrogen. So this one will overlap with this one, it can form a bond, and this one can overlap with hydrogen, it can form another bond. So how many bonds will form? You will get 2 bonds, and that's why the formula should be CH2. But you know, in methane, the methane structure is like this. It combines with 4 hydrogen and it produces how many bonds? 4 bonds. So how it is possible? Since carbon contains 2 unpaired electrons, since carbon contains 2 half-filled orbitals, it should produce 2 bonds. But carbon always produces 4 bonds. And that is the drawback of that valence bond theory. So some modification of valence bond theory you will get here. In case of nitrogen, as you have got, nitrogen contains 3 half-filled orbitals, and that's why it can produce 3 bonds. Oxygen 2 half-filled orbitals, that's why oxygen produces 2 bonds. But in case of carbon, it contains 2 half-filled orbitals, that's why it should produce 2 bonds only. But we know carbon have valency 4, carbon always produce 4 bonds. So although it contains 2 half-filled, how it produces 4 bonds, that cannot be explained by your valence bond theory. And that is why the new concept comes, which is called hybridization. Now I'll tell you what is hybridization. Now, as you know, the electronic configuration of carbon contain 2 half-filled orbitals. One is 2px and one is 2py. Valence bond theory said that this is the electronic configuration of carbon in the ground state. I mean, when carbon is alone, when carbon is in free state, then the electronic configuration of carbon remains as 1s2, 2s2, 2p2. But when carbon combines with some another atoms, for example carbon combined with 4 hydrogen or some hydrogen, then carbon undergo excitation. Excitation means nothing, carbon gains some amount of energy, and due to gaining of energy, one electron can jump from 2s orbital to 2pz orbital. Have you got it what I am saying? When carbon is in free state, when carbon is in isolated state, when carbon is in ground state, then the electronic configuration will remain 1s2, 2s2, 2p2. But when carbon combined with other element, then carbon undergo excitation. Excitation means it gains some amount of energy, and due to gaining of that energy, one of the electron from 2s orbital jump to the vacant 2pz orbital. So when the electron jump from 2s orbital, then 2s will contain one electron and 2p will contain 3 electron like this. One is 2px, one is 2py, one is 2pz. I mean one electron jump from 2s to vacant 2pz orbital due to excitation. And this is called electronic configuration of carbon in ground state, and this is called electronic configuration of carbon in excited state. That is why in exam, if the question asks write the electronic configuration of carbon in ground state, then you have to write 1s2, 2s2, 2p2. But if the question asks write the electronic configuration of carbon in excited state, then you have to write 1s2, 2s1, 2p3. This configuration you have to write. Now, after getting excitation, how many half-fill orbital? There are 4 half-fill orbital. So since there are 4 half-fill orbital, so 4 half-fill orbital can undergo overlap with some another 4 orbitals. Now, this is 1s orbital of one hydrogen, contain 1 electron. This is another 1s of another hydrogen, contain 1 electron. This is another 1s for another hydrogen. Since there are 4 hydrogen, so I will take 4 1s orbital like this. This 2s now can overlap with this 1s. It produce one bond. This 2px overlap with this 1s. It produce another bond. As you know, these are s orbital. S always produce sigma bond, so all will be single bond. I mean sigma bond. 2py overlap with this 1s. It produce another sigma bond. And this 2pz overlap with this 1s. It produce another sigma bond. So how many bonds you will get? You will get 4 bonds. But although carbon can form 4 bonds like this by overlapping with 4 hydrogen 1s orbitals, as you know, this overlap taking place between s and s orbital. This is 2s, this is 1s. I mean this overlap takes place between s and s. And this 3 overlap takes place between s and p orbital. You know, ss overlap is like this. This is called ss overlap, as the s orbital is spherical in shape. And this is called sp overlap. This is called sp overlap. P orbital is dumbbell in shape. And depending on the degree of overlap, you will get the strength of the bond. Already you have got. Here, degree of overlap is more. I mean strength of the bond will be more. Here, degree of overlap you will get less due to dumbbell shape. And that is why the strength of the bond will be weak. That means this bond will be stronger one, and this 3 bond will be somewhat weaker than this. That means methane contains 4 bonds like this. Among these 4 bonds, one bond is said to be stronger due to SS overlap, and another 3 bonds will be weaker due to SP overlap. But experimentally it is found that all the bonds present in methane, they have equal energy, they have equal in their length also. So how it is possible? As you know, SS produce always stronger bond and shorter bond. Bond is strong, I mean bond energy is more, bond length is less. SP overlap, length is long, but energy is less. So here, you should get different bond energy, you should get different bond length. But experimentally it is found that all the 4 bonds present in methane, they have equal in their energy, they have equal in their length. So how it is possible? That is why valence bond theory cannot explain about the formation of methane molecule, and that is why the concept of hybridization come. And if someone asks you from which molecule the concept of hybridization is coming, then your answer should be from methane molecule. Actually what happened? What is hybridization? Before overlapping with hydrogen 1s, these 4 orbital, I mean 2s and this 2p orbital, these 4 half-fill orbital, they undergo mixing. And this mixing of orbital is called the hybridization. And after mixing, they will produce some hybrid orbital. Since S combined with P, I mean S is combined with P like this, and that is why the shape of hybrid orbital will be like this. One lobe will be larger, another lobe will be smaller. These are called hybrid orbital. So hybridization means nothing, it is the mixing of orbital, and by mixing of atomic orbital, they will form some hybrid orbital. And how many hybrid orbital will form? How many orbitals involved in mixing? If 4 orbitals involved in mixing, you will get 4 hybrid orbital like this way, and that is called the hybridization. So hybridization concept is coming from the molecule methane. So now I will show you what is hybridization, how the hybridization takes place in methane molecule, and how they form the bond with hybrid orbital. That I will give you in the next video. Thank you.